Hey guys, Matty G here. I wanted to explain to you how to find the support reactions. So find the support reactions for the simply supported beam carrying a point load force of 100 kilonewtons. Alright, so I've got a beam here in blue. I've got a point load force of 100 kilonewtons acting right in the middle. Alright, and I've got two support reactions. I've got support A, which is a roller, and support B, which is a pin. Alright, and we've got a span length of 6 meters. Okay. Okay, so step 1, draw a free body diagram. Okay, so we've got our beam here in black. Alright, 6 meters long. We have a 100 kilonewton point force, okay, acting in the middle of the beam. And we have a vertical reaction. Okay, so at this point it's a roller. So we have only a vertical reaction, okay, which I've called RAY. Okay, so Y for being in the Y direction. Alright, and on the right hand side, we have RBY and RBX. With two reactions, one vertical, one horizontal, because it's a pin support. So it can't move laterally or horizontally, okay, at point B. At point A, it can move, okay, horizontally. Alright, so step 2, we're going to solve, okay, the forces in the X direction first. Okay, so how many forces do we have in the X direction? So we just have one. Okay, so we know for static equilibrium, the sum of the forces in the X direction, I'm making to the right positive. Okay, that's an assumption I'm just making, must equal 0. So the sum of the forces in the X direction are RBX, okay, equals 0. Alright, because we just have this one reaction force here. So this is equal to 0. Alright, so we can get rid of that. Alright, now let's solve for the forces in the Y direction. So for static equilibrium, we know that the sum of the moments, okay, must equal 0. And I'm assuming that the moments, okay, anti-clockwise is assumed positive. Alright, I'm assuming this. You can say clockwise is assumed positive if you want, it doesn't matter. And for static equilibrium again, we know the sum of the forces in the Y direction must equal 0. So upwards is positive. Okay, so that means downward will be negative. Alright, so that's step 3. Alright, so let's continue step 3. Alright, so I want to show you. Alright, so for the first part, if I've got a force here, 100 kilonewtons, alright, just looking at this force here. Now, if this force here, about point A, okay, will be this force. The moment will be this force multiplied by this distance, yeah, which is 3 meters. So if you think about it, that's going to cause the beam to rotate this direction, isn't it? It's going to want to rotate clockwise, yeah? It's going to want to cause the beam to rotate about A in the clockwise direction. So we know, okay, so we know clockwise will be negative because I've assumed anti-clockwise is positive. So the moment about A, okay, will be 100 multiplied by 3, but it's negative because I'm taking clockwise as negative. Alright, and then for the other force, okay, so I've got RBY now. Alright, so if I've got that force, if I have a force pushing upwards, okay, it's going to want to cause the beam to go up. It's going to want to go this direction. So it's going to create a moment this direction about A. It's going to want to cause it to rotate about A anti-clockwise. So this case, this moment, which is RBY, our force, times by our distance 6 meters, will be positive because I've assumed anti-clockwise is positive. So there are our two moments about A. Alright, so we're going to sum those moments, okay, about A up. Alright, so we know minus 300 plus RBY times 6 equals 0. So from this equation, I can solve for RBY. So I can add 300 to the left-hand side and add 300 to the right-hand side to get rid of this minus 300. This will become 0. So I'll just be left with RBY times 6 equals 300. Divide each side by 6. to get rid of this 6 here, and we can cancel the 6's out. So RBY will be 300 divided by 6, which is 50 kilonewtons, and that's positive. So that means we've assumed that the direction of the force is correct. Alright? So step 4, now let's sum the forces in the y direction. Okay, so we know we just found RBY to be 50 kilonewtons. Okay, so let's sum the forces in the y direction. So what do we have? We have RAY, which is acting upwards, which we're assuming is positive, plus our 50, which is our RBY, take away. So this is take away because the force, the point load force, 100 kilonewtons, is acting downwards, so it's negative. So now we have one unknown in this equation. So we can solve it for RAY, and we work it out to be 50 kilonewtons. So our solutions are RBY is 50 kilonewtons and RAY is 50 kilonewtons. Alright, so let's think about it, right? If you've got a beam, okay, you've got a point load force acting right in the middle, okay, so if it's acting in the middle, half of the 100 kilonewton load will go into support reaction A, and half of the 100 kilonewton load will go into support reaction B, vertically. Okay, so 50% of 100 kilonewtons is 50 kilonewtons. So that's another way you can sort of look at it. Thanks guys for watching. Please like my Facebook page and subscribe to my YouTube channel. And I'll speak to you guys later. Take care. Bye.